Hi everyone, welcome to Math Moment with Mr. Dustin. I am Mr. Dustin. So today we're going to be discussing geometric shapes and how to identify them. And this is the first of 3 geometry-centered episodes for the summer. And so this one today is more of an introduction to geometric shapes, both 2-dimensional and 3-dimensional, and we'll go over what that means. And it is really just like getting our terminology straight and trying to just identify these correctly for future reference kind of deal. And so let's get right into it. First, we have triangles. And so triangles are 3-sided 2-dimensional shapes. Now, what are dimensions essentially? So dimensions are kind of like length, width, height kind of deal. So you can see that this triangle here has a length and then it has a width. And you can consider that whatever you want, but it doesn't go, there's no like depth to it, because that would make it 3-dimensional. So you can almost think about it as like directions. 1-dimensional would be just this line, then 2-dimensional is this line and another line going in a different direction. And then 3-dimensional would be this line, the second line we drew, and then like a third line that goes in, if you can kind of imagine that. And we'll see some of what 3 dimensions gets you. So don't worry about that so much. But for our purposes here, 2-dimensional is kind of like a flat shape. So this triangle is a flat shape. And triangle is also known as a polygon. So what is a polygon? Well, a polygon is essentially a closed shape. A closed 2-dimensional shape. And so triangles are 3-sided polygons. That's kind of like the official definition here. And so within this, there are many different types of triangles. We can identify them based on their sides, and we can identify them based on their angles. And in the next episode, we're going to go over more of the angle aspect with the triangles. But what you really need to know is that they are labeled in degrees, and that's all that we need to go over for now. Once you get trigonometry, there will be another way to identify the angles. But again, for a different episode. And so if we want to identify different types of triangles by their sides, we are going to look at how the sides compare to each other. So let's look at the equilateral triangle first. Now, an equilateral triangle means all 3 of the sides are the same length. So you'll notice this is the same as this one and this one. And these like single lines through each side here signify that those sides are the same length. That's kind of the way of marking that on a drawing here. So equilateral triangle, all 3 sides are the same. Now an isosceles triangle means that 2 of the sides are the same. So we can see this one on the left and the one on the right are the sides that are the same. And you could tell by the line that was drawn through the sides. And then finally, a scalene triangle is a triangle that has 3 sides that are all different. So you can see there's a 1 here, and then a 2 here, and then 3 on that third side. And that signifies that all 3 of these sides are different. So in a sense, when reading that kind of marking there, you can tell because the markings that are the same are going to signify the same lengths, essentially. So let's look at identifying triangles by the internal angles. And those are going to be like inside the shape itself. So first we have a right triangle. And what that means is that we have a triangle with an angle that has 90 degrees. In other words, a right angle. That's what a 90-degree angle is. So we can see that right here in the corner. You'll notice that one side of it goes straight down and then the other, straight across. And that makes them perpendicular, which is another term for the creation of the right angle here. We also have triangles that are acute. And so acute triangles have angles that are less than 90 degrees. So no angles that are 90 degrees or more than that. So you can see this angle is smaller than 90 degrees, this one's smaller than 90 degrees, and this one is smaller than 90 degrees. There's also the obtuse triangle. And an obtuse triangle has an angle that is greater than 90 degrees. And so that's what they're highlighting in this bottom one here. It is more than 90 degrees, and therefore it makes the triangle obtuse. So those are triangles. And the big takeaway from this one is that triangles have three sides. Any of the specifics that I just said, you'll learn eventually, like in a high school math, like geometry course. So this will all be covered again. But for now, triangles are three-sided polygons. Now, quadrilaterals, those are four-sided polygons. You can see all of these are quadrilaterals, and the most famous of which would be the square over here. And now we have many different quadrilaterals here. All of them have four sides, but you can see all of these are different. So I'm going to go over what makes each of them unique. And again, the big takeaway here is that quadrilaterals have four sides. Any of this extra information is useful, especially for in later math classes, but not necessary to a middle school curriculum. And so this first one here, we have an irregular quadrilateral, also known as a trapezium. But the irregular quadrilateral is going to be basically not like any of the other ones here. So let's go over some of the other ones. This second one here is a trapezoid. That's what we will commonly refer to it as. And what makes a trapezoid is that it has one set of parallel sides. Now, what are parallel sides? Those are going to be two sides that are like they will never cross. If you were to continue these lines like out this way and this way, those lines will never cross each other. And that's what makes them parallel. So a trapezoid has those. Now a regular trapezoid, or an isosceles trapezoid, which is this one over here, will have a line of symmetry down the middle. Now a line of symmetry, that's a really bad one, essentially divides the shape in half. So if you were to look at each half, they would be exactly the same. So you can tell that the first one does not have a line of symmetry, but the other one does right down the middle vertically here. And that was a poorly drawn line, but I think we understand the idea here. The next shape is a parallelogram. Now a parallelogram, which is a mouthful, has two sets of parallel sides. So you can see the blue ones and the red ones are parallel. So the blue and the blue and the red and the red. A kite has two sets of sides that are the same. So you have these red ones here and you have these blue ones here. What makes the kite special is that the sides are adjacent to each other, or in other words, right next to each other. A rhombus has four sides that are exactly the same. So all four of these sides here are going to be equal. A rectangle is like a parallelogram, but it also has 90-degree angles everywhere. Like all four of the interior angles are 90 degrees. So that's what makes a rectangle and not a parallelogram. You'll notice that the blue sides are parallel and the red ones are parallel, and that is on purpose because they form the right angles here. And now a square, finally, which most of us are probably familiar with, has four sides that are exactly the same, four angles that are exactly the same, and those angles are 90 degrees. The square is essentially a combination of everything. And so that makes it really special. And we like squares in math. So those are the quadrilaterals. And you'll notice back to the irregular quadrilateral that it doesn't have any of these qualities that we mentioned. There are no parallel sides. There are no equal angles, no lines of symmetry, no equal sides. Yeah, none of that. And that's why it is irregular. Finally, we're going to look at some other polygons. And so this is before the break, finally. We already saw the triangle and the quadrilateral, which have 3 and 4 sides each. But we also have the pentagon, which has 5 sides, the hexagon, which has 6 sides, the heptagon, which has 7 sides, the octagon, which has 8 sides, the nonagon, which has 9 sides, and then the decagon, which has, you may have guessed it, 10 sides. And so you usually won't work with anything other than these regular versions of these shapes, but I like the terminology, and it has these prefixes and suffixes, and so those are kind of fun for those of you who are more into English. Another shape I want to highlight is the circle, and that has infinitely many sides, and we all kind of know what a circle looks like, so I'm not going to go into too much detail there. So with that, let's get into a break, and we'll get back into this in just a moment with some 3-dimensional shapes. All right, so for the break today, I decided to show you one of the things I've been working on in my free time. This is my Minecraft project. And for those of you who don't know, Minecraft is a sort of 3D modeling game, or it can be used like that. There's also like a campaign mode, but the way I'm using it today is the 3D modeling aspect. And so you can see my 3D model here of what is a Venator class Star Destroyer from Star Wars. And so I like to replicate things and try to see if I can design them and then basically just kind of like run through them later on. So I'm going to bring us in closer, but I will also add a picture right here to show you what it's supposed to look like. And so then you can maybe be more impressed by what's here, or maybe not. It's okay either way. And so a lot of this was math. I used a ton of math and fractions to do this. And I'm showing this in this episode because it has a lot to do with shapes. And you can see that each of these is a cube, which we are going to talk about in the next segment of our video here. But what I had to do is I had to calculate different angles at which to increase. So let me show you a particular spot. Now this spot may seem insignificant, but in the drawing, or the picture I was going off of, it was kind of a big deal. So you can kind of see, we're looking at a triangle. I don't want to move too fast, but there's like a, you can see this is going down and then across the way here. So I had to figure out how far in one direction it would go and how far in the other direction it would go, and then figure out how to connect them in such a way that it looks like a triangle. And so we're going to get into how to calculate that in the next episode. But these are right triangles, which we talked about, and that's kind of fun. And so yeah, this is just kind of a frame of the whole thing. And for those of you who are curious, this top section is where the bridge is, which is like a command center, so to speak. So what will happen is there will be a window here that you can kind of look down on the rest of it from, which is kind of fun. So this is kind of like the shapes side of it. And I figured I'd show you because there was a lot of math that went into it. And you can see on the bottom there, I had to make it increase at certain rates, or like increase in height. And so a lot of work goes into this kind of thing. So at home, if you have this game, or if you have any other kind of modeling system, I encourage you to run with that and try to make your own creations, especially using math, because that is a lot of fun and it will look really awesome when it's done. So I'm also going to show you one more thing in this game, and it has electrical engineering applications to it. And so I figured I would just include it here while I'm talking about this game. And so we will cut to that in just a moment. All right, welcome to our electrical engineering section of this video. And this is an application, so to speak, of kind of what electrical engineering can be, although I have no personal experience in that field. But this is some contraption that I designed, or stole the design to use on my project. So what it does is it opens up right from the middle there. and excuse the lag, there's a lot of this kind of thing here. And so let me just kind of show you what goes into making this thing run, and it'll be easier if I close this up. It opens and closes when I press this button here, which is awesome. And so what I do is I run a signal, almost like an electrical signal down here. And these things here keep the signal going. So the signal goes to this little thing here, which keeps the signal traveling all the way down to the bottom here. When these things activate with this signal, it'll tell these other parts at the top here to move, which will then carry the red part with it. And so that's the thing you're actually seeing is the red part opening up. And so kind of electrical work here, because you have to figure out where the signal is going to go, how far it has to go, and then keep it alive essentially. And you have to figure out what kinds of things conduct it. So that's the electrical aspect of it. You can see I have many failed attempts at signals and everything over there. But this is the successful one, and I think it will work really well for what I'm looking for it to do, which is to have it open and to close. You can see, again, there's the lag. So for those of you looking to go into electrical engineering, this could be a good step to at least getting yourself introduced with electrical engineering. So if you play Minecraft, this is redstone, just any kind of redstone contraption. And so this doesn't really have much to do with shapes, but I figured I would include it in that video because I included the other Minecraft segment. And I will also show you what a finished project in Minecraft could look like. I built a building from Star Wars, which I'll include a picture for, and that was kind of a finished product of calculating angles and all these other things. So I'll include a clip of that. But I hope you enjoyed this segment on Minecraft, and we'll see you for the next segment of the video. Hi everyone, welcome back. I hope you enjoyed the break. Let's get into some three-dimensional shapes. So this first one on the left here is called a cube. Now what a cube does is it's like a square, except it has 6 faces that are equal. So what is a face? Well, a face is like one side here. So there's a face here, there's a face here, there's a face here. So if you think of like a Rubik's Cube, that's kind of the idea behind the cube here. We also have what is called a pyramid. Pretty sure I spelled that right, pyramid. And what's special about the pyramids is it has a base, which is that square on the bottom, you see, and then a bunch of sides that come up to a point at the top here. And that's how you can identify a pyramid. We also have what is called a rectangular prism. Now that is a mouthful, but essentially it's like the cube in that some of the faces are squares, but it also has some faces that aren't equal. So you have these longer faces here and then the smaller ones. And so that's what kind of makes a rectangular prism that way. We also have some three-dimensional shapes that are curved. And these are a little trickier to know. and they're not as frequently used. So first we have a cylinder, and that is this shape over here. If you think about like a Pringles can, it is a cylinder because there's a circle on the top and the bottom, and then the rest of it wraps around to, and that's from a certain height. So circles on the bottom and the top. That's kind of an easy way to identify a cylinder versus these other shapes. We also have a cone. Now, this may not look like a cone. Those of you who might be used to like an ice cream cone, I can actually probably flip that image around. Let's see. Now you might be able to see it like that. This is a cone, and so you can imagine your ice cream at the top of it. And basically, it's like the pyramid, but it's curved around the edge. So the base is a circle, and then the rest of it is curved up to a point. And so that's kind of how you identify a cone. And then finally, which is one of the most fascinating shapes, is the sphere. Now, the sphere, if you want to connect it to something in real life, is like the globe. The Earth is a sphere. And so what the sphere is it's a completely circular three-dimensional object that is, yeah, it's just all circles. So it's curved on every side you can imagine. And that's what kind of makes it a sphere. I don't have like a way to interact with this shape and kind of spin it around, but if I did, it would look pretty much exactly the same because it's all curved like that. So to summarize, triangles are three-sided polygons, quadrilaterals are four-sided polygons, circles have infinite sides, and then you can see I have a list of the pentagon, hexagon, heptagon, etc., with how many sides they have. The three-dimensional shapes, while important, are not as heavily emphasized in the middle school and high school curriculum. And so I figured just identifying them here would be enough to kind of get a rudimentary knowledge for them. So the real takeaways from this are the triangles and the quadrilaterals. These are shapes that we're going to work with much more often in high school and middle school. And so I figured I would emphasize them more, which is why I spent so much time on triangles and quadrilaterals at the beginning here. So that is it for this video and this introduction to geometry. In the next video, we're going to go over some triangles and kind of look at some special qualities that right triangles specifically have and why we care about them so much. And so thank you so much for watching. This is, this is episode 7 of 10. And so there are quizzes that can be done after each of these math videos. The link is in the description of the video. And those quizzes are only going to be up until the end of the summer reading program. After that, you won't be able to access them. So if you'd like to take the quiz to kind of informally test your knowledge, I would appreciate it. There's also a feedback section if you want to give feedback on these videos, and to let me know how I'm doing here. So again, thank you for watching, and we'll see you next time.